Good morning, friends. We are learning our subject, that is data mining 3160714. And in that, we are learning the module 2, and that is data pre-processing. We want to learn correlation analysis, right? But why do we want to learn that? For that, let us see the previous lecture content, so we can know why do we want to learn correlation analysis. Okay, so let's see. We learned that handling redundancy in data integration. When we are doing the data integration, at that time redundant attributes can be there. So what? Redundant attributes may be able to be detected by correlation analysis and covariance analysis. So we want to know correlation analysis. So what is that? For correlation analysis, there is one chi-square test. So what is that? Let us see the equation of it. It is chi-square. This is written as x square, capital X square. It is said as chi-square. Okay. Chi-square is equal to sigma observed minus expected whole square upon expected, right? That is, we can say sigma O minus E whole square upon E, observed minus expected whole square upon expected, right? What it does, it tests whether two categorical variables are independent or not. As for example, divisions and degree classification. The larger the chi-square value, the more likely the variables are related. Correlation does not imply causality. So, what do we say? Whether they are correlated or not. Both are causally linked to the third variable, and that can be the population, right? So, we are not talking of the causality, but we are only trying to find whether the relation is there or not between two variables. We have talked of for correlation, that is at least whether the relationship is there between two variables or not, where we have talked of that one variable is increasing and other variable 2 is increasing. That is what? That is, you can say, the positive correlation, right? Both are increasing together. If one is increasing, other is decreasing, that is called negative correlation. And if one is increasing or decreasing, no effect on the other variable, that is said as no relation. Fine. So what do we say about the chi-square test? We are having the hypothesis. We calculate the expected values, use the observed and expected values to calculate the chi-square test statistic. P value, that is what? It is equal to probability, and what do we say is chi-square is greater than chi-square data based on the hypothesis. H0 is the hypothesis. It is said as the null hypothesis. Now what it is, we will understand very easily using the example. Fine. Establish the significance level you need usually 95 percentage. That means the p value, probability value, is equal to 0.05, and the number of degrees of freedom, what it is, that also we'll see. Compare the chi-square statistic with the critical value from the table. See, what we have to do is we have to calculate the chi-square value from whatever equation we have seen. And the second thing is we have to find the critical value from the table. I'll show you that table, and we have to compare that, whether the chi-square calculated is greater than or equal to the critical value from the table, right? And based on that, we can say whether the two variables are in relation. That is, you can say whether they are positive related or negative correlated or no relation, right? So we are trying to find whether two variables are there in relation or not. That is using chi-square test. Fine. Okay. So what is the degree of freedom? Number of degrees of freedom is calculated by multiplying. See here, multiplying the number of rows minus 1 by the number of columns minus 1. The degree of freedom we have talked of here. The terms degree of freedom, right? We have considered that. We have considered critical value. See, this now how to find. That's what we are learning. Okay. So degree of freedom, how to find? That is calculated by multiplying the number of rows minus 1 by, that is multiplication, the number of columns multiplied by 1. So what we are having is multiplication of rows minus 1 multiplied by columns minus 1. Okay, this way we can find the degrees of freedom. For a 2 cross 2 table, that is 2 minus 1 into 2 minus 1, that is equal to 1. Hypothesis that variables are independent and dependent, right? So what do we say is H0. Null hypothesis always says that whatever two variables we are trying to find, they are independent, and H1 is the other hypothesis which says that two variables are dependent. So here we want to see the example, that is where you can say chocolate and vanilla. Two things are there. So are they dependent or not? That's what, if we want to find, then how we say that for null hypothesis, we say H0, that is chocolate and vanilla are independent. And H1 says chocolate and vanilla are dependent, right? Now, what we are finding, we are trying to find whether two variables are related or not. Fine? Okay. So, if the test value, whatever we calculate, the test value, what we calculate from the equation, that is chi square is equal to O minus E sigma O minus E whole square divided by E, right? With this, we are calculating the value. So that calculated value, that is test value. If it is greater than the table value, then reject the hypothesis. Which one? Null hypothesis, right? H0 is called the null hypothesis. So we reject it. Reject it means what? It means what we have considered in the H0, that was chocolate and vanilla are independent. But if this test value is greater than table value, what do we say? Reject H0. That means this independent was there, rejected. That means those two variables are dependent. Fine. Okay. Confidence value is 95 percentage, and then we can say that find the probability, that is equal to 0.95, and df, that is the calculated one. How did we find the df? That is degree of freedom, rows minus 1 into columns minus 1, right? Now, what do we say is we need to use this probability and this df to find the critical value from the table, right? Table I'll show you, and from that we need to find the value, right? Which is value? What is the value? That is the critical value we will find from the table. Okay. And then we'll see what this condition. If the calculated value from whatever equation we have seen, chi-square equation, right? That if is greater than whatever value we are finding from the table, then reject the H0. Fine? Otherwise, accept it. So now, performing a chi-square test, how we can do that? Calculate the chi-square data value from the data. Look up for the corresponding p-value in a table giving the cumulative chi-square distribution under the independence hypothesis with the correct number of degrees of freedom. Reject H0 or not at the chosen significance level depending on the p-value found, right? Nowadays, R tool and Python-like language do step 1 and step 2 for you. That is, whatever we are performing here, these things are being calculated by Python and R-like tool. Okay, you just have to compare the p-value to your significance level to conclude the C in the above step. Fine. Let us see the example. You can understand it very easily that how we are calculating it. Okay, let's see. There is a table given to us where expected and observed frequencies are given and the total we need to find. Right? It is not given, that we need to find. Okay. You can see somewhere we have seen that we have to find the expected values. Where was it? Use the observed and expected values. Calculate. No. Fine. Okay, no issue. Whenever the expected values are not given, at that time we have to calculate it ourselves. Okay. Keep that thing in your mind. If expected values are not given, we need to calculate it. How? That we will see. Fine. Just now, let us consider this particular example and. Try to find what? Try to find whether the chocolate and vanilla are independent or not. So for that, we are having the two hypotheses. Null hypothesis says that chocolate and vanilla are independent, and H1 says chocolate and vanilla are dependent. What we know is whatever test value we know. No. What we calculate using the equation of chi-square, if it is greater than that which we'll be getting from the table value, then reject hypothesis. Right? This is what is known to us. Now let us calculate the example. We can have the idea. Chi-square calculation we want to do, right? For chocolate, what do we say? O minus E whole square upon E. Only that? No, we need to find the summation of it, right? So what we are doing is O minus E. O, what is O for chocolate? 39. What is E? 25, right? This is observed, this is expected. So 39 minus 25 square. Divide by E. So value of E is available here. You can say summation was there, where it is. See here we are finding the individual items and then after we'll do the summation, right? So what do we say is, for vanilla, what do we say? 61 minus 75, that is observed minus expected whole square, divided by 75, that is expected one, right? So that's what we are finding here. O minus E whole square upon E, right? So that is the value we are getting. Now what to do is, we need to find the square value of it, isn't it? We need to find the square value of it. Square value? Not square value. We need to find the summation of it, right? Chi square is where we are having O minus E whole square upon E. That's what individually we have found, right? This is for chocolate, this is for vanilla. Now we need to do the summation. So chi square value, that is equal to the summation of this two individual value, right? So we are not doing the chocolate square or vanilla square. When we are writing this x square, we know that it is chi square, right? So what we'll do is, whatever is the value we found for chocolate, that we'll put, and whatever value we have found from the vanilla, that's what we'll put here, do the summation. So that is the chi square value calculated, right? Chi square value calculated. Now, degree of freedom, that is equal to 2 rows and 2 columns are given. You can say, ma'am, here also the total is there. Total is what we calculate. It is not given, right? So what do we say is, total we require for some process. If so, we'll do that, okay? Otherwise, you may skip it, no issue. So what do we do? Degree of freedom, that is equal to 2 minus 1 into 2 minus 1, that is equal to 1. Alpha is equal to 0.05 because 95% confidence level is given. For this particular problem statement, 95% confidence level is given. So from critical value statistics table, there the DF and alpha is given. So what is that? With that, we need to find the value of chi square. That is from the table. Okay. Table should be given to you. Then you can find from that. Okay. There you can find the DF is there, as well as this alpha is there. And from that, we need to find what is the chi square value from the table, right? We'll see. Just now, let us assume that suppose 12.84. Suppose, I'm not saying it is this only, right? From the table, when we are having the table, we can see the value. Okay, just now, let me say that assume that if the value is 12.84, what we want? We want to check whether these two variables are independent or not. So for that, we know that if the test value, that is whatever we have calculated from the chi square equation, if it is greater than what we found from the table, then reject the null hypothesis. Null hypothesis says that chocolate and vanilla are independent. Okay, so we can say what value we got from the calculation, that is 10.45, and let us, the way we have assumed that whatever we are getting from the table is 12.84. This is assumption, right? For example, no assumption should be there, but just now I'm not showing you how to work with the table, right? So that's why I have put one random value and I'm showing you how to find the answer. Fine. Okay. So what do we say is 10.45 is the calculated value, and what we get from the table is say 12.84. So what do we say? Should we reject the hypothesis? Null hypothesis? No, we should accept it, right? So what was our hypothesis? That was saying chocolate and vanilla are independent, right? So independent, that means there are any relation? No, there is no relation between chocolate and vanilla, right? Now, here, what is the case? One more example is given to us. The blood group is here, observed frequency and expected frequency is given to us. So what we need to do? We need to find the chi-square. How do we find that? It is known to us, that is sigma O minus E whole square upon E, right? So let us say that chi square value which we calculate, that is, for example, I mean, you will calculate that is using the formula as I told you. It is 17.0481. Then DF is 3 and P is equal to 0.0007 is given to us. Then in the chi-square table, it is having the value from say 6.25 to 7.81. So what do we say? Whatever is the test value, that is greater than whatever is the chi-square table value, because it is 6.25 to 7.81. So some value between this. So what do we say? What do we say for that? That is, chi-square calculated is greater than chi-square table. So what do we do for that? If it is test value is greater than the table value, we reject the hypothesis, right? So whatever we have started with, whether those two variables, they are having the relation with the other variable or not, that will be false, right? That will be false, right? Whatever variables you consider, 2 means o a o b o a b, whatever you consider, for that will see that no relation is there, right? Now one more example. What do we say about that? Play chess, not play chess, right? Play chess, not play chess. That is what is given to us. Like science fiction, not like science fiction. The things are given like this also. What do we say? Observed one is 250, and whatever is given in the bracket, that is the expected one, right? We know that O minus E whole square upon E. Only that? No, we have to have the sigma for that, right? That is the chi-square equation. Fine? Okay. So now we want to have the equation of chi-square. We want to calculate that, and then after we can say that from the critical value table, we need to have the value of that chi-square, compare that and check it out whether it is greater or less, and we can say that whether we should accept the null hypothesis or not. Fine? So like science fiction and not like science fiction, do we have any relation or not? What do we say is not like science fiction, sorry, like science fiction, not like science fiction. These are the things given for play chess and not play chess. So what we are finding is it shows the like science fiction and play chess are the related group. How we can say that? See, for that, what we need to consider is chi square we need to find. O minus E whole square. 250 minus 90 whole square upon E, that is 90. Then plus, what we are doing is 50 minus 200, this one. 50 minus 200 whole square upon 210. Plus 200 minus 360 whole square upon 1000, sorry, 360, that is the expected one, plus this 1000, that is observed one, minus 840 whole square upon E, that is 840, right? And we can find that 507.93. Now with this value we should compare whatever is there in the table, right? If the value, which value, this chi square value, if it is greater than whatever is there in the table, then we'll reject the null hypothesis. That means the like science fiction and play chess are correlated, they are not independent. Fine. So very simple equation we need to find, and if the table is given we need to find the value from that, otherwise it will be given to you. For example, that the chi square value from the table is this one. Okay. Till now, I haven't found that the table is given to you and you need to find the value from the table, or otherwise you can find that, okay? It's not so difficult. Correlation coefficient, correlation analysis we want to have. What did we do? That was the chi square test, okay? Chi square test, with that, what we find is we find whether two variables are related or not, right? The same thing we can find from the correlation analysis. One is the chi square test and second one is the correlation analysis, and that is for that we need to have the correlation coefficient. Fine. For that, here typically we are using the Pearson's coefficient. So what is that? RAB, that is equal to sigma AI minus A bar BI minus B bar upon n minus 1 sigma A into sigma B, right? So what are sigma A and sigma B? They are the standard deviations. And standard deviations formula we used to say like under root of sigma x minus x bar whole square upon n. So what do we say about A bar and B bar? They are the mean, isn't it? They are the mean values. Fine. So what do we say? If R, whatever we calculate from this particular equation, if this value is greater than 0, then A and B are positively correlated. RAB is equal to 0, then they are independent. And if RAB is less than 0, the two variables, that is A and B, are negatively correlated, right? Were we able to say these things from chi square test? From the chi square test, we were only able to see whether the two variables are having the relation or not. That is whether they are independent or not, that only we can say. But with this Pearson's correlation coefficient, we can say whether the two variables are positively correlated, negatively correlated, or they do not have any relation, right? That is, you can say they are independent. Fine. That is from the value of this coefficient. If it is greater than 0, we say positively correlated, less than 0, negatively correlated, and 0, that means they are independent. Fine. So, if the example is given to you and you need to find whether two variables are independent or not, that you can find two ways. One is using the chi-square test and second is using the Pearson's correlation coefficient. But if it is being asked to you that whether the two variables are positively correlated, negatively correlated, or they are independent, if we want to find that, then you have to use the Pearson's correlation coefficient, right? So read the problem statement properly so you can do that. Fine. So this is what we have talked of. What do we mean by positive correlation? What is mean by the negative correlation? And what do we mean by the no correlation? Right? Till now we were talking. Now we can see the figures. So you can understand that very easily. See, both the x and y variables are increasing. Both the values are increasing. That means that is the positive correlation. Both x and y increase together. That is the positive correlation. When you can say that one is increasing but other is decreasing. So that is what is called the negative correlation. And whether there is increase in one variable or decrease in one variable, there is no effect on the other variable. That is the no relation, right? That is no correlation. Okay. So correlation measures the linear relationship between the objects. To compute correlation, we standardize data objects A and B and then take their dot product. Fine. So you can say how to find. See, the simple formula is given to you, right? That is the maths only. Whatever data is there, you just have to apply with this equation. Find the value of R. That is the Pearson's correlation coefficient. And then you need to check it out for this one, right? Whether it is greater than 0, less than 0, or equal to 0. Fine. Based on that, we can say it is positively correlated or negatively correlated or no relation. Fine. Okay, so next what we want to learn is, we can say, covariance. As we have already talked of the relation between two variables, we can find with the help of correlation or covariance. Fine. So correlation we have seen. Now we want to know about the covariance. So what is that? Covariance is a measure of the relationship between two random variables. The metric evaluates how much, to what extent the variables change together. See, variance, we used to say that change, isn't it? Variance, typically we used to say change. So what do we find with the help of covariance is the metric evaluates how much, to what extent the variables change together, right? Unlike the correlation coefficient, covariance is measured in units. The units are computed by multiplying the units of the two variables. The variance can take any positive or negative values. The values are interpreted as positive or negative covariance. What do we mean by positive covariance? It indicates that two variables tend to move in the same direction, right? In the same direction. We do not say only increasing together. They can be decreasing, no problem. But the thing is, both variables tend to move in the same direction, right? Okay. So if the negative covariance, that means it reveals that two variables tend to move in inverse directions, right? So what is the equation of the covariance? That is equal to sigma xi minus x bar into yj minus y bar upon n. So let us see the example. We can understand it very easily. Fine. The data is given to us, that is year is given, and then after the data for two companies are given to us. What do we do is, first of all, let us find the mean for company 1 and company 2, that is S&P and ABC Corporation. Fine. Let us find the mean of it. We know that mean means what? It means summation divided by number of data. Fine. So that's what we are doing. We are finding the mean for the S&P company, as well as we are finding the same for the ABC Corp. Right. So for both the companies, we have found the mean of our data. Now, what we need to do is, we need to find the relation between the companies, right? Companies data, we need to find the relation. So for that, what do we want to do is, we need to have the formula, that is for covariance, there whatever is to calculate. So you can see, what was there? Xi minus x bar, right? Xi minus x bar and yj minus y bar and upon n, right? So we need to find that. If we say this is xi minus x bar, whatever mean we have found, right? So this is there, and we need to have sigma for that. So we'll find the summation of it, isn't it? Whatever difference we are getting, then after we'll find the sum, okay? Then yi minus y bar. That is what? That is what is this one, right? It is this one, yi minus y bar, right? That's what we are finding. And then after, what we are doing is, we need to have the multiplication of both, right? Do we need to find the sum of this one, sigma of this one and sigma of this one? No, we do not need that. We need to have the sigma of multiplication of both, right? So here we are doing the multiplication, and then after we are doing the sum. Divide by n, that's what we need to find, okay? So the result of the covariance of these two companies, that is equal to, you can say, whatever is given, right? Whatever we are finding, okay? Fine. That's what we have found. Okay. No. Here it is n, right? It is not n minus 1, isn't it? So we can say it is 4. You can calculate the value and you can put it here. Fine. It is very simple, isn't it? It is the formula where we are having the multiplication of those things, the xi minus x bar and yj minus y bar upon n is there, right? Oh. How many data were there? 5 or 4? What was there? 1, 2, 3, 4, and 5, right? So 5 we should specify, okay? And we'll find the answer, okay? So you can calculate and you can have the final answer. We can calculate it here also, no issue for that. What is that? 36,429.2 divided by 5, right? I am calculating in my calculator. You can calculate in your own, and what we are getting is something like this. Fine? Okay. So whatever is the equation, you need to put the values in it and find the value. Okay. That is what is the covariance. Fine. This is greater than 0. So what do we say? That these two variables are in positive correlation. Okay. Now, covariance is similar to correlation. Fine. Now, what do we want is we want to have the relation between the covariance and correlation. Correlation says that whether two variables are related or not, that is using chi-square test. Second one, what we found was the correlation coefficient, where we can say positive, negative, or you can say no relation. Fine. Then we have found the covariance, that is using simple way, and we can say whether the we can have the relation of positive, negative, or 0. Fine. And now what we are having is, you can say, covariance and correlation, the equation between them two. If uh, you are directly given the Pearson's coefficient, and then after you can say that covariance is given to you, what you can find, is you can find the relation between those things, right? What is the relation between the covariance and correlation? That is what is given to us. That is RAB, that is equal to covariance AB upon sigma A into sigma B, where n is the number of tuples and are the which one? A bar and B bar here in this equation, that is A minus A bar, B minus B bar is given to us, and for that we can say that it is having the what? The A bar and B bar are the means, isn't it? Very simple. So expected values of A and B, they are the A bar and B bar respective mean, right? Respective mean. Okay. And sigma B are the respective standard deviations. Okay. Positive covariance, where we can say COV is of AB is greater than 0, then both are having the what? Both tend to be larger than the expected values. Now, what we are doing is, here we are saying that whether they are the larger than the expected values or not. Fine. Negative covariance, what it says. If it is negative covariance, then if A is larger than its expected value, B is likely to be smaller than its expected value, right? If covariance, what we are trying to find is less than 0, what we say is A is larger than its expected value and B is likely to be smaller than the expected value. What we are trying to find here is something different what we were having before, right? Here, what we were saying is whether they are having the covariance positive or negative. Here we are trying to say that if this value is greater than 0 or less than 0, what do we say about that is whether A is larger than expected values and B is smaller than or not. That's what we are trying to find, right? Larger or smaller, that relation we are trying to find, right? And independence, for that we can say that covariance of AB, that is equal to 0. But converse is not true, right?